Okay, first lecture block on Media and Brain 2. It is about semantics. Which is a big word, actually. The meaning of it is rather unclear, and there is not so much theory, actually, to explain it, what it actually means. Very simply put, semantics requires symbols. Symbols might be letters, for example, might be Chinese language signs, might also be icons, emojis, for example. Symbols might be words as well, so there might be aggregates of more fundamental types of symbols, having a meaning on a different level. And that is the most important word in the thing, is these symbols are loaded with meaning. Now think of the concept of language, for example. There we have symbols in the forms of the letters. These are the most prominent ones. Presumably, many of us would think first of symbols in terms of such letters. And these symbols are aggregated in order to form a meaning. By white space separated, meaning can be, the symbol might be house, based on letters, and everybody of us knows the meaning. The concept, however, is, even for such a simple word as house, very broad. That, however, is not the topic of this lecture, but of the next lecture video when we deal with knowledge and norms. There we will introduce a notion, the so-called concept theories, and deal with the idea of how you actually can store information of concepts that are non-fundamental, that are not so easy to explain, such as what is a house. If you think of a house, it might go from a simple hut up to a skyscraper. So it's actually a very broad definition. Okay, so the lecture block is on semantics. Two major ingredients are symbols, whatever they mean. By the way, language is not just a question of letters. Before the letters come phonemes and formants, how we actually form the letters when we speak the language. And these are loaded with a meaning. And how do we do that, and what types of meaning we can have, is part of this lecture block. So, what are we going to discuss in the next maybe 25-30 minutes is that we will speak about the so-called image theories. Image theories link symbols to their meaning. So from here to here. That is the major part of this block. The second one is to go into the details of semantics in language. I just named two levels, the level of the phonemes and the level of the letters. That brings us to the level of the words, but there are way more, and we are going to discuss these. And then we will deal with a neural network for aggregation and representation of semantics, not just in language, but in everything that happens over time. Most of our knowledge is based on temporal proceedings. Some of it is also static, but actually we live in a world of space and time, and therefore everything happens over time. So these are the three ingredients of this lecture block. Why is it important? As I told you in the pre-lecture meeting, I revised the list of topics. Last year we were mostly interested in processes of perception and cognition. This year we are more specific we want to understand more about the symbolic domain, because this is really where our culture, where our knowledge is actually situated. So most of the seminar tasks, and in particular in Media and Brain 2, are based on semantics. Therefore, we need a thorough introduction into this area. With this block, I hope I can provide the necessary input for you to enable you to do your own research on ideas and methods. In particular, in the third block, this is this one here, I would like to give you also a bit of an example of how you can actually conduct your research. Furthermore, just a little note, there is one of the best papers of last year is online as a reference paper. It was on will and willpower and how it can be modeled neurally in the human brain. If you're not sure how to do your seminar paper, read through this one. It is a very nice example. Of course, it can be improved and can be done differently. As I said a couple of times, be bold, try something, be playful as well. But this should be a guideline of what it actually could look like. Okay, having said that, let's start with the block. Let's try to find out how the meaning of symbols can actually be gathered and expressed in terms of semantics. First thing to do is have a look at image theories. Matter of fact, we already encountered an image theory. We encountered the notion of Plato, who said that, or one of the first people that we know of, thought about the differentiation of reality with what we actually perceive. This is what we call today the so-called hard problem of functioning versus feeling. He didn't go on that neural level, that was not known at the time, of course, but he already introduced two terms that we spoke about. One of them was the Eidos, and the other one was the Eikons. Eikons, apparently the root for our word icon. If you remember, then the differentiation between the two topics was in particular that Eidos is a relation by the idea, by the overall theme, we would say today. Let's put this here. Whereas the icons is a relationship by certain properties. So, taxa, as they are also called. There is a connotation here that what is property-based can actually be counted. So it's about things that are present or absent, so-called predicates, and these can be counted. If it's about the general theme, it's usually about sizes, about colors, about the extent to which something is present, about quantities in comparison or in contrast to predicates, and these can be measured. So a first indication for you is distinguishing those two relationships is whether or not something can be counted. For example, if you think of animals, one property might be wings present. If wings are present, it's very likely to be a bird, for example. Wings present is a predicate between the actual artifact, the living animal, and our perception of it, our view, our visual perception in particular. Okay, as I said, measurement is about quantities. Whereas counting is about predicates. Okay, and this here is about thematics. Well, that was Plato 2,500 years ago. already a lot of information about how we can distinguish these two concepts. So to cut the long story short, that was it, and nothing more happened in the next 2,500 years. No, that's not true, of course not. Otherwise we wouldn't be doing this block. So we are speaking about image theories. And Plato's view was revised a couple of times. One time actually very early by Aristotle. Aristotle, in his endeavor to build a taxonomy of everything, of all the phenomena that he would encounter in the world and what he had learned from others, so to build encyclopedic knowledge, as we would say today, said that, well, these two relationships between something and the image we have of it are certainly important and might be actually the two most important notions that we have. But they are not all relationships that could be thought of. And when he formalized it, he came up with two more. The third one was, for him, the causa efficiens. Causa efficiens meant a relationship by cause and effect, the reality and the image. Image could, for example, be that a house is burning, and the effect is that you actually see smoke rising from the roof. The fourth category would have been the causa finalis, which is the purpose. Okay, so let's put this here. Causa efficiens is cause and effect relationship. And causa finalis is about purpose. Use relationship. Okay. Let's put them here again, make them distinguishable. These are two more relationships. Okay. Aristotle also gave new names to the Eidos and the Eikons. For the Eidos, he developed the name the causa formalis. So the relationship by the form, and related it to the Eidos. And for the Eikons, he would use the name causa materialis. In our modern terms, think of what constitutes actually the reality, what materials are required in order to form the reality. And that is then the causa materialis. Okay, so these were the four causes, it's better, that Aristotle came up with. So these four relationships actually held for a very long time, and the basic idea is, to repeat that again, is that if you perceive something, the image is your perception. So last in the videos on media and brain, when it came to psychophysics, the image would be the psi, and the reality would be the phi. Okay. The relationship between the two is defined by one of these four causes. They actually held for a very long time, basically until Hume introduced a fifth notion. He agreed that these relationships would also be there. Causa formalis he would call a syntactic relationship. Causa materialis, the iconic relationship, he would refer to as semantic. Cause and effect, he would just call cause and effect. And the relationship by the purpose, he would call a pragmatic relationship. Why did I name Hume's taxonomy of possible relationships? Because of two terms in particular, or three terms actually: the introduction of calling something semantic, the idea of distinguishing semantics from syntactics, and by this word, a pragmatic relationship. That is also a term that is still in use today. However, he gave us also a fifth relationship, and that fifth relationship was contiguity. And contiguity just means co-appearance. So you cannot actually explain it, but something happens together with something else. That was a fifth new relationship that he defined. Okay, so you see they are actually already summing up the individual theories of what images could actually be to certain realities. There is a fourth that I would like to name, which was defined to a certain extent by Roland Barthes, a French philosopher, one of the fathers of semiotics, and he would actually not introduce new relationships, but rather clear the table and make it a bit easier to understand, and calling any form of relationship by the form or by the material an iconic relationship. Whereas the cause and effect relationship would be called indexical. An indexical relationship would mean, as I gave in the example before, that something is symbol for something else. If I see smoke, then I might conclude that there is a fire nearby somewhere. That would be the indexical relationship. And contiguity and pragmatic relationship would be summed up to a symbolic relationship. Okay. So, what's interesting about what he introduced is that mostly he developed this notion of relationships between an image and a reality, or actually any two instances of symbols that we can interpret, might be based on nature terms, on things that are, if you want, reasonable and imaginative. They might be indexical, of course, but there is this idea that they might be purely symbolic, based on our cultural development. And that is a new notion that we should be aware of. Last thing that I would like to mention in this block is that a contribution that was made by Wittgenstein, and before actually the introduction of the semiotics, was that he would refer to such a relationship as a family resemblance. A family resemblance is something sometimes, in particular when it comes to the dialogues between human beings, as something actually very dangerous. Family resemblance might be that for a whole sequence of terms and of arguments, of points in discussion, you might, for example, jump from a syntactic to a semantic explanation relationship back and forth. That is what psychologists would call a thematic taxonomic bridge. Think, for example, of the relationship of a ball, a balloon, and an airplane. A ball and the balloon have a similarity by the Eidos, because most of them are mostly round. The ball is round, the balloon is round. A balloon and an airplane have clearly a iconic relationship, or a semantic relationship, as Hume would have said, because both of them share the property that they can fly. The balloon can fly if it's gas-filled, and the airplane can fly if it is functioning. Now, since we have three terms and two of the terms are related, one might assume that there is also a relationship between the ball and the airplane. However, there isn't. This is called a thematic taxonomic bridge, because two terms are related by the theme, two other terms are related by shared properties, and there is no relationship between the outer two. Why is that dangerous? You might embark on such an argumentation when whatever your goal is, and it might be help your goal. However, even though it appears purely rational, it links terms that are not linked together and that don't share any common meaning, any common semantics, and therefore you use a rational tool in order to create something irrational. And since this is mostly ignored by the general public, it is a very harmful and dangerous way of arguing in a semantic way. Okay, having said that, to sum up the image theories, Plato introduced the notion, distinguished one from the other, theme, measurement, quantities, from counting, taxonomic predicates. It was extended by other causes. It must be said as well that for us, of course, the first two are the more important ones, no doubt about that. When it comes to the brain, it's of course sometimes about cause and effect and a purely pragmatic relationship. For us, however, in the focus we have a semantic from a purely syntactic differentiation. That is what we are mostly interested in. So, why is that important for us? We want to understand what semantics actually are. It's about symbols. Symbol means that some artifact stands for some other artifact, one being the image, the other being the reality, and semantics is about understanding this meaning. So the meaning is actually in the focus of the semantic understanding. That was it for image theories. Now let's have a look at what we have in terms of language and try to model that neurally. Okay, so what can language be? A dreadful thing indeed, if it's not your own, as I can tell from experience. Okay, language has many levels. In particular, we have the words, and on the other end we have the sentences. But that is not where it ends. We have phonemes. So, spoken language actually, very important. After the sentence we have the paragraph. And even harder, the dialogue. Yeah? Between the word and the sentence we have objects that are bound together by grammar to sentences. So there are all sorts of relationships between these individual concepts. If you look at it, there's really lots of different forms that can come along. However, they do share a few properties that make them hard for us to process in the world of natural language processing, and that means that language is always over time. To speak a sentence we need time. To describe what's in the sentence mostly we need to deal with different times. Something might be in the present, it might be in the past, it might only appear in the future and therefore be uncertain. So time is on various levels a very important concept that we have to deal with. The question is, how can we do that on the neural language? And in that context, I would like to give you a very brief example of how that could actually be described. Think of the following scenario. We have present in our system, let it be a neural system, let it be a hopefully conscious system, we have present three words, word 1, word 2 and word 3. So we are already past a stage where we recognized phonemes into building letters, and from the letters building words. That's another important constituent of language, is letters actually. So this is all very mixed here apparently already. Anyway, as a brainstorming it might suffice. You see that there are different levels. Okay, so let's go back to the example. We have 3 words, and those are the result of semantic enrichment through applying neurons of all sorts. Now we consider ourselves to be at the stage of grammar recognition, so going from words to objects and sentences. In order to recognize grammar, we might want to be interested in identifying a structure such as having a noun, a verb and another noun, and those being part of a sentence, one being the subject, the other the predicate, and the third one an object. The question is, how can we actually deal with that? Or how can we actually develop a neural pattern that guarantees us that the subject becomes for the predicate, becomes before the object, so that we can already recognize simple sentences. Not any variations, but only simple sentences. A very simple idea from my side would be to feed the first word into something that I call a slow decay pattern that could in the simplest form be 2 neurons that are activated by some input here from the word, and then feed forward each other through tonic firing for some time. So allowing neurotransmitters to go back and forth over the synapses, and at the same time always providing an output and only decaying very slowly, so that this output is present for some time. Let's say a second, 2 seconds, for example. That is what I call a slow decay pattern. Could easily be implemented with standard neurons that have a tonic firing pattern, which in essence means that the threshold is very small. Is a very small value, and therefore whatever as input comes along is being fired again. Such neurons, by the way, of course, do exist in the human brain. They are used in many stages. For example, in the very early stages of visual recognition in the bipolar cells, and in the more complex pattern of the ganglion cells based in the bipolar cells. Okay, so if we have such a slow decay pattern, it means that the first word feeds into it, thus creating an image that is held for some time. If we have that, we can use a standard neuron with the input of the second and the input of the slow decay pattern, so this side over here, and use the output, if it's beyond the threshold, as a sequencer for the first word and the second. If you think of this pattern, then this word must come first, otherwise this activation contribution is not provided. If after the first one, the second one comes, we have a sufficient potential in order to make the pattern fire. If it's the other way around, and the first word, W1 comes only after W2, we would actually have lost the second signal. It would have fired, the activation potential would not have been exceeded, and therefore that input would not be there anymore. So in the wrong direction, W2 before W1, the pattern would not fire. Okay, now if we feed that again into a a slow decay pattern and just wait for the third one, then we actually already have achieved the pattern that we wanted. We have a pattern now that guarantees us that word 1 comes before word 2, and the two of them together become the word 3. And that might allow us to include semantically that this is actually a simple sentence of subject, predicate, and some object. And that is a fundamental act of semantic enrichment. Now think of it, because this is something really central to our lecture as well. Our general problem is that we have input from the perceptor cells. We must enrich it in the network in order to arrive at conclusions on the semantic contents of the world in which we live in. We do that, so far as sure, by using neural patterns in the central nervous system. We also know today, or we have the strong assumption, that what we call consciousness is also part of that central nervous system. So consciousness must be explainable in terms of neural processes. If we want to understand consciousness, we have to understand semantics. Semantics is mostly based on language. If you make up your opinion of what you're doing tomorrow, you use so-called inner speech, so you hear yourself talking, you form sentences, you do language semantics. In order to understand language, one very important step is that we bring words into order, into sentences, by grammar analysis, implicit by the way, this is something completely implicit. Meaning that you can be completely ignorant of the grammar of the language that you are using and still be successful in using it actually, so you don't have to be a grammar scholar in order to express yourself to others and yourself. And with this pattern, which is completely neural, very simple, just on every level, requires 1, 2, 3, 5, 6 neurons. In a simplified form, of course, the pattern will be redundant and much bigger. It's 200 to 500 connections between two neurons that actually belong together to the same pathway or processing chain. It would already be possible to do this simple form of semantic enrichment and derive from words at simple sentences. Now comes one very important aspect of this whole process, and that is the conclusion or the recognition that what we have here is not yet meaning. What we have here is a sentence. This is something grammatical. If we go back one page to the different image theories, then what we now have achieved is syntactic, grammatical analysis, relationship by the theme. Theme meaning that, okay, the subject comes before the predicate and then comes the object. If it looks like that, the sentence, then apparently it is of interest for us. But this syntactic relationship is not yet a semantic one. What we have to achieve in our endeavor to find artificial consciousness, and of course on the lower level of providing the building blocks to achieve this endeavor, is to get from the syntactic view, sentence recognized, to the semantic view, what is the actual meaning of the sentence. So, here's my theory how that could be done. I have read a couple of books on the topic and I've been reasoning about it now for years, but it's still just my personal theory, influenced of course by what way more intelligent and way more successful scientists actually have found out. What I personally believe is the case is that with that grammar pattern we could abstract from words into word categories. Exactly here. So that the grammar analysis would, to a degree, only be done later, or, if necessary, maybe fed back into this layer. It is also agreed that there is feedback in this loop. So, what is a word category? A word category, by my understanding, is nothing taxonomic, in the sense that we would actually here aggregate to a grammatical category of, as I said, pronoun or reflexive pronoun, to be more specific, and different types of verbs. No, word category is meant in a pragmatic sense. So all a word category would be to run. Running might include walking, actually. Might include maybe swimming even. And many other forms of different moving in a given direction, in a relevant, semantically relevant direction. So the idea is that if we go from the individual words and filter them down into certain hypotheses of word categories, and only then build the sentence, then we are actually not on the level anymore that this is a particular sentence, but this is a particular relationship between word categories. Okay, the second one being here running, the first one being person, human being, the third one being bank. Bank can be many different things. It might be an automatic teller machine. It might also be a building where you actually speak to a human teller. And it might be a number of other categories. There might be different subtypes, actually. Shops that are doing bank functions and post offices, whatsoever. And if we have human being, running, as we said here, plus bank, we might have a meaning already after this pattern, of course, of ordering, of sequencing, that is far beyond the simple grammatical stage that we have here, but arrives at a conclusion that somebody is actually doing some urgent money business. So the idea now would be that the words are actually split up into all word categories where they might actually belong. That is, to a degree, a syntactic process by simple aggregation in the different word categories. Those are then sequenced into the meaning patterns that we have here, and the output is not just grammar, it is implicit, it is not explicit, but the output is a meaning. That would explain two things. First, it would explain how we get from sentences to meaning. That is a very important step in language semantics. And secondly, it would explain why we are also successful at using language without understanding the grammar explicitly, but apparently understanding it implicitly. So this hypothesis that I presented might be for you of interest for doing a seminar task. You can look out for such a pattern, but it should also be on the meta level, be of interest for you as an example for what you can also do, actually. You can also, based on the given literature, give reasons and arguments why a certain pattern would make sense. That is actually requested, so it is actually a play field for you. But there is one limitation. It always has to be neuron-based. It always has to be based on patterns that can actually be implemented by what we know about synapses. Let me repeat that again. I expect you to provide in your seminar paper a generative view of your aspect of artificial consciousness that you are dealing with. That means that everything has to be explainable by neural network methods and mechanics. For that, you should read the first chapters of the book by Kandel, Schwartz et al. On the human brain, so that we have a common understanding of these neural mechanics. You should read the literature in the field of your topic, come up with such patterns like the brain tiers that I mentioned in the media and brain lecture, but also this gating pattern for the sequencing of language, and then think about how to get on the semantic level. Semantic, as I said, means a relationship by shared properties. The problem of semantic is how do we arrive at the predicates? That is the real fundamental question. And we can arrive at predicates when, surprisingly early, we go from the individual word to the word concept by aggregating over a whole group of terms that have been recognized as words, summing them up together and defining thus implicitly their shared properties. In the next block of the lecture we will go through this idea in detail, not with this example probably, but on a more general level when we speak about concept theories and think about what can be done to define the central meaning, the typical meaning, and all the connotations of a particular term. Okay, having said that, there is one more thing that I would like to mention. Let's have a look at the roadmap again. The roadmap was, I wanted to introduce you to the term of image theory so that you get a first understanding of what the relationship of two terms might actually be. An image and the reality was the original idea of Plato. But it can be there any relationship between two more or less semantically loaded concepts. Then we wanted to speak about language, because this is the fundamental constituent of what semantics in the consciousness part of the brain necessarily must be. Visual and audible symbols are all very nice, but only the processing of language is actually able to explain complex goal setting, self-motivation, and the other functions of artificial consciousness. I always say artificial, but actually I mean more natural. In order to build artificial consciousness, we have to understand natural consciousness, and that is a task big enough for the next 50 years. So, it's just an habit to call it artificial consciousness. So the last thing was this neural pattern, and in this context I would like to give you a very brief final insight on the pattern and tell you that this is not just for language. This is for everything that I would call a temporal. What is a temporal? A temporal is something that is sequenced over time. That is apparently language. That would also be speech as a small sub-pattern. There, however, the semantic enrichment is very simple. As you know, we just go from from a complex wave pattern by frequency analysis to critical bands, and those are then used to form formants and phonemes, and from these formants and phonemes we conclude on individual symbols in our letter-based view in the Western world. No, other temporals that are interesting are, for example, recognizing movement over time, so recognizing something as a fundamental symbol as a hand, for example, then seeing that the fingers make different moves, like forming a fist, for example, or being spread out, and with that we can then again associate the higher semantic meaning of an aggressive pattern versus a friendly pattern. That might have a meaning in the body dialogue between two human beings encountering each other. But that is beyond the limit. The point is, whatever we have as input, concrete inputs to abstract inputs, the sequencing of the temporal in order to eventually arrive at the meaning is done in the same way, by my opinion, storing in a short-term memory of some sort the individual ingredients and adding simply up what comes later, and that guarantees that only the desired sequence can actually lead to the firing pattern of the semantic concept. So the final conclusion is, if it's about semantics, it's about recognition and semantic enrichment of symbols. These symbols are abstracted into word categories, symbol categories, and only then I believe they are sequenced. And that input might lead back to a refined understanding of the semantic load. Thank you very much.